Okay, seems I'm not getting the font that I'm looking for, but we are now at around 150. Seems is a good number. Now we can start. We are looking at measures of dispersion. Measures of dispersion. That's where we are today. Measures of dispersion. Just a continuation from what we were doing yesterday. Measures of dispersion. It's our topic today. I don't know why this thing is misbehaving. We are looking at measures of dispersion, as I said. So let me just do the introduction. Let me see whether now it will give me what I'm looking for. Okay, measures of dispersion. Measures of dispersion. And under measures of dispersion, can you see the handwriting?
Yes.
All right. Under measures of dispersion, today I want us just to concentrate on only one. There are several, but the key one that is of my interest today is variance. Variance. So I want us to discuss variance. Variance. And just like the name suggests, variance is variations. How do numbers vary from each other? So anytime we're talking about variance, it's just numbers, variation of numbers. But there's something that I told you the other day when we were looking at measures of central tendency, is in statistics, we are not interested in an individual's either score or performance. For example, anytime I'm announcing results at the end of the term, we don't focus on the individual student. We focus on the class as a group. So we will say the mean for 4A is this. The mean for 4B is that. Not the mean of a student like Olu. I'm not talking about Olu. I'm not talking about the mean of Xavier. I'm not talking the mean of Caleb. I'm not talking the mean of Johnston. I'm talking about the mean of the class. Very soon we'll be getting KCSE results. Once we get the KCSE results, we will not be talking about the mean of the best boy. We'll be talking, the means of the best boys will still be there, but generally we'll be talking about the mean of the school. But the question is, how did each individual student contribute to that mean? So the focus is groups, not individuals. When we are talking about incomes, salaries for people working for a certain industry, we look at the mean earnings. When we are looking at the harvest, we look at the average harvest. When we are looking at anything, shoe sizes, we look at the mean shoe size, because our concern is the performance of a group, but not an individual. So in statistics, we don't focus on the individual, but we give the aggregates for the groups. So let's look at now how that variance works. And I want to start from a very basic understanding. We all remember what is mean. What did we say mean is? Just an individual, just one of you to remind me what is mean. Am I audible? Yes.
Yes.
Oh, good. If I gave you a data set, like how many subjects do you take? 8. And I give you marks for chemistry English, mathematics, up to the 8th subject, and ask you what is your mean. How do you calculate that mean?
Find the average.
You find the average. True, that's English. Put it in maths now.
The sum of all the numbers divided by the
Very good,
number of
David.
numbers.
You add all the numbers divided by the number of subjects you are doing. That is what we call ungrouped data. Just as we did yesterday, we started with ungrouped data, then we went to grouped data. And we said the mean, which is as simple, x bar, is given by adding all the numbers. When I write x, I mean the number of x's that you have. Sometimes we add I to mean the first x, second x, up to the last one, and then I divide by their total. When I do that, I'll be looking for the mean. So for example, if now I decided, I just thought of a data x, and in that data x, I give you numbers. Like maybe you did a cut and the cut was marked out of 15. And the one of you gets 3, another one gets 4, another one gets 6. Let me do maybe 8, 9, and the highest students maybe gets 12. And since we said we don't deal with individual students, we want to deal with a group. If I ask you, what is the mean of that group? What would be the answer? Work out the mean of that group. We are taking, how many students are they? 1, 2, 3, 4, 5, 6 students have done that exam. What is their mean?
7.
Very good. I'm assuming you added all these numbers. And when you add all these numbers, they're adding up to what? It is 3 plus 4.
42.
Plus all of them up to 12. I'm told the answer will be
42.
42.
42.
So what is 42 divided by 6?
7.
7. Very good. So the mean of that class, a class of 60 students, maybe these are guys taking French, or guys taking German, or guys taking music, those small groups. So a group, a subject with 7 students. No, a subject with 60 students. The lowest got 3 and the highest got 12. Then you work out the mean. We'll be saying the mean for music is, hello guys, the mean for music in that cut is, am I alone? What's the mean for that group?
Oh, no.
I can't hear you. Any person can answer.
7.
I can't hear you.
7.
It's very good. 7. So if this was a group taking a certain subject and those were their scores, the mean is 7. Now there's something Mr. Mburu taught you about deviations. Deviations, where we were saying deviation is given by x minus assumed mean. Do you remember that? Okay, I'm assuming you have heard my question. Now, I want us to look for another kind of deviation, which I will still call deviation, but this time round, it is x minus the real mean now, the real mean. So it means I need a column that talks of x minus the real mean, where x is the marks each student got, and the x bar is the mean of the group. So we want to find the deviation in terms of how did the student who got 3 deviate from the class mean. For example, if somebody got 3 out of 15 and the mean of the class is 7, what is the deviation? Work out that deviation. What is x minus
Pardon?
x bar?
Please pardon.
Yes, I'm saying we worked out the mean for this group. Let's say it's a music group, and we say the mean is 7, just the way we have gotten 7 here. But I'm asking, after getting that 7, we want to work out deviations. And let me use the spotlight so that you can see. Here, I've said deviation. Initially, we said it is x minus assumed mean. However, today, we want to look at another form of deviation where I'm taking the mark, which is x, minus the real mean, the mean that you got. For example, the mean for this group was 7. So what are the deviations? So to work out the deviations, we get a column of x minus the mean. So in our case here, x is 3 and the mean is 7. So what's the deviation here?
Negative
What
4.
do we record there?
Negative 4.
We record
Negative.
-4. Thank you. So that becomes -4. What is the other deviation? The next row,
Negative 3.
Negative 3.
-3. Let's keep working out.
Negative 1.
-1.
1.
1.
1,
1.
2,
2. 2.
5.
5.
and a 5. Very good. Once you reach there, there's something that is very important that I want us to learn. Let me first erase this so that I have space. There's something that is important that I want us to look at here now when it comes to measures of dispersion. We have now seen when I work out the deviations, the answers that I'll get are shown there: -4, -3, -1, 1, 2, 5. I want you to add the deviations, summation of x minus x bar. Give me the total. Add those deviations down. What total do we get?
0.
Very good. Write 0. That's accurate. Then write somewhere in your notes, if you are making some notes. Anytime, or rather, the sum of deviations, from the real mean or from the actual mean will always add up to 0 or will always be 0. You know, we said this is also called deviation. So if I'm summing deviations from the real mean, the answer will always be 0. That's factual. Because I used the numbers to calculate the mean, and I used just the same mean to subtract from each number. So when I add, this total will always be 0. Anytime I do that, the answer will always be 0. Have we picked that?
Yes.
Now, so the moment we get 0, then it means we cannot proceed. That is the end of that working. Because if I take x and I subtract the real mean, and when I add, I get 0. That becomes the end. And that is the beginning of variations or dispersion. I'm working out the variations from the mean. Those deviations now we call them variations. The sum of the variations will always add up to 0. However, when we get 0, that does not mean we have come to the end of the road. We should now think of mathematical approaches that can allow us to proceed with the working of the variance. So how do we proceed? To proceed, we think of a mathematical transformation, a mathematical change, a mathematical operation that is going to change our numbers from adding up to 0 to adding up to something. And the only logical transformation here is to change the negatives to be positives. These negative signs here, this negative, this negative, this negative. The question is, mathematically, how can we change a negative number from negative to positive? What operator changes a negative number to a positive number? Oh, guys, are you thinking? We are saying there are only four operations in mathematics. I'm adding, I'm subtracting, I'm multiplying, I'm dividing. There are only four. So out of the four, which one can convert my number from a negative sign to a positive sign?
Multiplication.
Negative.
Yes.
Multiplication by a negative.
What we are going to do here, now we are going to square these deviations. X minus X bar, then I square it like that. I square them values. So let's square those numbers. When we square, what are we going to get? 16.
9.
9.
1.
1.
4. 25.
Now, can you give me the total now? What is the total of that square?
56.
Sorry? Summation of x minus x bar squared equals to what?
56.
Somebody has already said the
56.
sum is 56. If I remember the sum here, I think somebody said it was 42. Was the sum of x 42?
Yes.
Yes.
Good. Now, we have three very important sums there. The first sum was adding x's. The second sum is adding x minus x bar. And the third sum is adding x minus x bar squared. And then we have said the first x is the raw marks. The raw marks that every student got. Then we use their total to find out the mean. But we subtract the mean from each score to find the variations. Like we can say, the first student was 4 marks below the class mean. The second student was 3 marks below the class mean. The student who got 6 was 1 mark below the class mean. So it's like those 3 students had a negative contribution to the class mean. When we come to the student who got 8, he was 1 mark above the class mean. The student who got 12 was 5 marks above the class mean. And we said those are called the deviations from the mean. When we add the deviations from the mean, we found the answer is 0. But we say that 0 is useless. We can't proceed. So we look for a transformation that will change the negatives and the positives, which now we squared. Once we squared, now we added, and the sum makes sense. And because we were looking for variations, that square is what we're going to use to get the measure that is called variance. And therefore, what is variance? I told you in statistics, we are not interested in the individual score. We are interested in the group. For example, when you look at the first x, when we got 42, we divided by 6 to get the mean. So we say the mean of the group is 42 divided by 6, which was 7. That was the mean of the group. The second one, we could do nothing because it's 0. Now the third one will give us the mean of the variations from the mean. Let me take it again. The third column will give us the average of the variations from the group mean. The group mean was 7. We worked out the variances, then we squared them. So the variance now becomes summation of x minus x bar squared But because we are not dealing with individuals, we add all of them, divide by the group, the number in the group. So we have already realized this will add up to 56 divided by 6. And what is the answer? You gave me 56, yes, and they were 6. So what is 56 divided by 6?
9.33.
9.33. That is what is known as variance. Variance, which is a single number describing the group. The way we have mean is a single number describing the group. Variance is also a single number describing the group. So for the mean, we are saying the average for the group is 7. But now here we are saying the variation, the average variation is 9.33. And now that leads us to the final measure of dispersion, what we call standard deviation. And the standard deviation is given by the square root of the variance. And what's the square root of 9.33?
Ndio maana inakata kuandika. Nikijibu tuko wengi hata njua.
Baraka Katama, can you be on mute?
Afunzi hizi streams zote ni kwamba ingia form 4 ni form 4 wao wote.
Baraka Katama.
Kuna wanafunzi ajui.
Baraka Katama, can you be on mute?
Unafanya hii upuzi yenye unafanya utaharibu. Tuache kukaa nayo.
What is the square root? Forget about that one.
Ni ya kuandika peke yake. Hii upuzi nyingine
3.055.
3.055. That becomes the standard deviation. Yes? Yes?
Excuse me, teacher.
Yes.
Can the variance be written also as a fraction, or should we stick to decimals?
Yeah, it can be written in n form, no problem. Who can reach this guy called Baraka Katama? They are making noise for us. Baraka Katama. Katama. This guy is not even listening.
Maybe Edward can mute him. I see the host today is Edward. Edward, try muting him.
Sorry.
Katama.
Yes, sir.
You are making noise for us and telling us things we don't want to know. We don't want to know what you have in your head, Katana. Switch off and mute. So we're saying, once we get the variance, the next thing we get is a standard deviation. What is the logic of taking the square root? Remember, for us to get the variance, we squared the deviations to make them positive. That means in the process of squaring, we changed the original numbers. The original number was x, but after subtracting, we have squared. So to go back to the original units, which were x, we take the square root of the variance. And once we obtain the square root of the variance, that number that we get is known as the standard deviation. So we have three very important measures now in hand. Number one, mean. Number two, variance. Number three, standard deviation. Mean is the average of the x's. Variance is the average of the deviations, but of course they were squared to kill the negative sign. And the standard deviation is now the square root of the variance to go back to the original units that we had used. And those are the three measures of, okay, well, the first one was a measure of central tendency, of course, the mean. And then The variance we have now, measures of dispersion, we have looked at variance and the standard deviation using ungrouped data. Any question? Have we understood? That silence is, you can chat in case there's something you are not sure or you want to clarify.
And is a derivative of.
You don't need to unmute if you don't want to talk. Just you can chat in case there's any clarification. But that is basically the two measures of dispersion or spread, variance, and the standard deviation. And the logic is well laid out there, why we are squaring and why we are taking the square root. Key thing to take home is in statistics, we are not interested in the individual, we're interested in the group. So we can see the mean of the group, the variance of the group, and the standard deviation of the group. Mr. Mburu? I think I heard Mr. Mburu.
Excuse me, teacher, could you pardon the part of standard deviation?
Standard deviation, we said
Yes.
Standard deviation is the square root of the variance. Remember, our variance was 9.33. Then we took the square root of that. Sorry?
Okay, thank you.
Yes. And the reason we were taking the square root, I said, is because for us to get the variance, we squared. So we are simply undoing. We are going back before we had squared because, you know, the original units were not squared. The marks were 3, 4, 6, 8, like that. But for us to get the variance, we squared because of the negatives. So we take the hello. Mr. Mburu.
Yeah, good morning.
I can't hear Mwalimu. Is Mwalimu here?
Good morning.
Yes. Mr. Mburu, I think you can pick it up from there. Hello?
Yeah, thank you. Mbithi.
Mr. Mburu, I can't hear you.
Good morning.
Morning.
Good morning.
So my audio, I hope, is okay.
Yes.
It's fine, teacher.
Okay, so we proceed. I was saying that my bit would be repeating the same thing. That is getting variance and standard deviation. But now we use grouped data. Remember what Mwalimu has done? He has done for non-group data. That is, we take marks that are standing on their own. A student getting 3, a student getting 4, a student getting those kind of marks, they stand on their own. Now for group data, this is where now we group them into classes, assuming now we have a spread of score between maybe 1 to 100. Then we say the first group will be the students between 10 to 19, 20 to 29, and so on. So we group them, we put them into groups depending on the classes that they are in. I believe we had talked in depth about that in the previous lessons. So I'll not overstress on that. So therefore we go straight to maybe a examples. Trying to see if I can reach my just a minute. I hope you're able to see my screen from your end.
We are able to share.
Yes?
Yes.
We can see.
Okay, now
Yes, we can.
let's put some table where maybe we'll put some data. I want some columns, just a minute. Okay, I believe that will be okay. So the first thing we do is put the mark. Then we can put, normally we have X. Then we'll talk about maybe F. Let's have a class maybe running between 10 to 19. Then we have 19, let's say, not 19, but now 20, 20 to 29. Then we take another class, let's say 30 through 39. Then we take another class 40 through 49. Maybe we can work with those 4 classes. So in the previous class, that is in the previous discussion we had discussed how to get the column X. So how do we get column X? Somebody to remind us how we got column X. I hope that font is visible from your end.
Yes.
Okay, now how do we get column marked by X?
Midpoint.
That is our midpoint, correct? So we say 10 plus 19 divided by 2, you get what?
14.5.
You get 14, 14.5. Then the next class will be 24.5.
24.5.
Then we go to the next class, we have 34.5. Then we can have another class, let's say 44.5. Then you can give some random frequencies. Let's say here we have 3. Here, let's say we have 5. Here we have 6. And here we can give a number like 4. Okay. Now, remember, we started by saying that our deviation is being obtained by how far is each mark away from the mean of the whole data. How far is each mark away from the mean of all the data? So that tells you that the first thing you do, given such set of data, is to get the mean of the class. So that tells you that the first thing you do is to get the mean of, not the class, but now the whole set of the data. Maybe I can give you 5 minutes to calculate the mean. And remember we said that mean of X, that is bar X, is equals to summation of Fx over summation of F. So maybe we can create a column, call it Fx, so that eventually you'll have a summation of Fx over summation of F. So 5 minutes, because that is an answer. So once you're done, maybe the first person can tell us what they are getting as the mean of X. That is sigma Fx over sigma F.
$30.61.
That is 30.61. Can somebody else confirm that that is the mean?
Confirmed.
So the procedure was get X, get F, get the product Fx. So at the third, maybe can move on together. That 30.45, then you multiply that by 6. That is 207. Then lastly, I have 44.5. 44.5. I multiply that by 4 because F in that row is 4. I get 178. Then I'll get the sum of this column here, Fx. What did you get at the sum of that column?
551.
551.
Yes.
Then I divide by n, n being sigma f. In most cases, like in your log table, they have said over n. So n means a total of f, that is sigma f. So what is my sigma f?
18.
So that now when I divide that, I'll end up with, you got
30.6. 30.61.
30.61. 30.61. Now that is my bar x. That will be my bar x. And now I want to get deviation of each mark from the bar x. So I'll have another column where I will key in my x minus x bar. X minus x bar. And remember, Mwalimu has said that summation of x minus x bar will give us 0. If we were to do x minus x bar, we are going to get 0 because we use the same marks to get x bar. Then we are trying to see how far from the mean are all the marks now put together. They will take us back to the mean. So the deviation is 0. The deviation is 0 from the mean. If we were to add all the deviations together, we'll have 0 deviation. Those that scored less got negative deviations. Those that scored more than the mean mark got positive deviations. So the positive deviations cancels the negative deviation. So sigma of deviation gives you 0. So that tells you, instead of now having the column for sigma for deviation, just x minus x bar, we have now a column for D. And what is our D? Deviation. We negate, or rather we make sure that the D does not give us 0, we square it. So we can call that column, the column x minus x bar, but now squared. Remember the D is deviation. D is deviation, and how did you get D? We said it is x minus x bar. How far away from the mean is each mark? How far away from the mean is each mark? So we have a column for D squared. What is D? Deviation from the mean. Why are we squaring it? So that we get rid of the negatives, so that we can sum up positive numbers, so that we can have a number we can work with. Remember, with a 0, we'll get stuck and stop there. 0 came from the negatives canceling out with the positive. Now we don't want to work with negatives, we square it. So that's why we are squaring the deviations. Now we work row by row. In the first row, our x is 14.5. So how far away from 30.61 is 14.5? So we say 14.5, we minus 30.61. So what do you get?
Negative 16.11.
Negative 16.11. And remember, we are avoiding negatives because eventually they will cancel out with the positives later. So instead of using the negative, we square the deviation. So what are you getting as the square of 16 point? Square that, what do you get?
259.5.
259.5. Then we go to the next row. In the next row, we have 24.5 as our mark. That is our x. So we ask ourselves again, how far away from the mean is that 24.5? Because the 24.5 represents the whole of the class 20 to 29. So how far away from 30.61 is 24.5?
Negative 6.11.
Negative 6.11. Again, remember we are avoiding negatives. So we square the deviation so that we now fill in the column for deviation squared. What are you getting after you've squared?
7.2.
47 point?
37.33.
7.33.
We have that is 7.33. Then we go to the next row. In the next row, we have our mark as 34.5. And remember the question is how far away from the mean is that mark? So how far away from that is 30.61 is 34.5?
3.89.
Now this 3.89 will cancel with some negatives that we had above there. So we cancel out the negative by squaring the negative. So again, this positive should also be squared. Remember, we are squaring D. So after you've squared, what do you get?
15.1.
15.1?
3.
13.
Yes.
15.13, that's okay. Then finally, we have the row for 44.5. We have a row where the mark is 44.5. So again, how far away from the mean is 44.5?
13.89.
13.89. 13.89. Sorry. Square that 13.89.
192.9.
190.
192.
192.9. So remember, when we were doing non-group data, we got the summation of deviations. We got the summation as the summation of deviation. We just added the deviation the way they were because each deviation had a frequency of 1. Each deviation had a frequency of 1. Like that student who got 3, his or her deviation was 1 student times their deviation. The student who got 4 was 1 student multiplied by their deviation. The student who had 12 was 1 student times their deviation. Then we added all the deviations together. So in that case, the F was 1 because each mark had only 1 student. So each mark had only 1 student. So that tells you now, in the scenario where we are using group data, we will now put F, D, then we get the square. Why are we putting F? Because we have said that when we're dealing with the non-group data, we were only saying D squared because F in each case was 1. So there was no point of saying F times D squared. But for group data, we have F varying. Like in the first class, our F is 3, our F is 5. In the second class, our F is 6, our F is 4. So this deviation from the first row is brought in by 3 students. The deviation squared we are getting for this row, that is 259.5, is coming from 3 students. The deviation 37.33 is coming from 5 students. The deviation from 15.13 is coming from the 6 students that were in the class 30 to 39. So that's why for the group data, we are introducing the F so that we get now each class had how many students, and these students we multiplied by the deviations for the total deviation. So the column, the last column there will be FD squared. For the non-group data, we just got sigma D squared over N. But here, because each class has a different number of students, or there are some students in each class. The class 10 to 19, we had 3 students, which gave us the deviation 259.5. So we get the product 3 by 259.5. What do you get?
$778.5.
778.5. Now again, we go for each row. The next row, the deviation squared was 37.33, and we had 5 students.
186.5.
Okay. Then the next class, the deviation squared was 15.13.
Excuse me, Shade, 186.7.
186.7.
That is the class of 20 to 29.
Yes.
Yeah.
186.7.
Yeah.
Yes.
Okay. Now the next class, the deviation squared was 15.13, and that class had 6 students. So what do you get? FD squared?
90.78.
90.78. Lastly, we have a class that has a deviation squared of 192.9, and that class had 4 students.
Hata maneka mwenyewe
What do you get? There's somebody to tell that guy to keep quiet because I can't hear.
770.
Stay on mute.
Hey, Wakahiu, karaoke. Karaoke. Wakahiu. Wakahiu, karaoke.
Messi alicheza. Mbappe alicheza, yes. 3 goals.
Karaoke, Wakahiu.
Somebody to reach out to Wakahiu.
Yes.
Yes.
Karaoke.
Yes.
You are making noise for us. We are not in soccer game.
Okay, let us proceed. We were in the last class where we had the deviation squared as 192.9. And from that class, we had 4 students. So we get total deviation, that is the number of students times what we had as D squared, as 771.6. Now, remember, we said that variance now will be the average of these deviations, the average of that deviation. So that tells you we need to look for summation of FD squared. we get summation of FD squared. So add the column FD squared. Somebody to add that for us very fast.
$1827.58.
1827.58. So we say therefore that variance equals
1827.58.
1827.58. We divide that by
18.
n. Our n is 18.
Sigma F.
So we get what in as a quotient?
101.53.
101.53. Somebody to confirm that that is what they are getting?
Yes. Yes.
Okay. Now that will be the variance for that grouped data. That will be the variance for that group data. Remember, the procedure is the same as the non-group data, only that for group data, each class has a different number of students, or it has some number of students, not like the non-group data where each mark was coming from a single student. So that's why we are just saying sigma d squared over n. Here we have a different number, or rather a certain number of students contributing to that deviation. In the first class, we had 3 students contributing to the square deviation of 259.5. So we multiply that because there were 3 students. Then in the next, we had 5. We multiply by d squared so that we have the total contribution from the 5 being 186.7. The next deviation was 15.15. However, we had 6 students contributing to that square deviation. So we say 6 of them multiplied by the deviation, we get 90.75. Then lastly, we had a deviation squared of 192.9, which came from 4 students that were in the class 40 to 49. So we get FD squared. So therefore, our variance will be sigma FD squared over sigma F, or over N. So summation of FD squared over, just a minute, over summation of F, or capital N, where N could be sigma F. Now, for standard deviation, we were told that this is the square root of variance. Standard deviation will be the square root of variance. So what is our standard deviation?
10 points.
10.076. 076. Standard deviation will be the square root of variance, which is 10.076. Standard deviation is the square root of variance, which is 10.076. So far, do we have any question?
Yes, teacher. I'm asking. As we were doing the calculations, we found out that the decimals had very many decimal places. Are we supposed to make sure that all our answers are in 4 significant figures, or there are no penalties for any number of decimal places?
I believe the 4 significant figures is the best way to go about it. 4 significant figures. If you're having very many decimals, take 4. Unless, Mr. Mbithi, there is any variation from that.
Yes, a good question, young man.
So make sure that you round them off to 4 significant figures. Like work with 4 significant figures, but in most cases, I've just used some random data in most cases, you will be given, the question will come in a way that you will not be having very many decimals. The question will be set in that you don't have very many decimals, but in a situation where you see that we have non-terminating decimals, we have recurring decimals, round them off to 4 significant figures. You round them off to 4 significant figures. Now, so that we can optimize on our, the log table that we work with. In the formulas for the formulas found in log table, we have 3 different methods or formulae of getting variance. I don't know whether you have access to your log table. We can have more than one. Some questions will tell you using this get standard deviation. Sometimes they will just leave you to make use of whatever you know. But for our log table, it is talking about sigma f into x minus x bar. Then we square that over n. So it is sigma f into x minus x bar over n. Now, if you are careful, you will notice that it is almost the same thing that we are working with. Only that now we are saying d squared. But at the back of your mind, you should know how d came about. Then number 2, why are we squaring it? We should know how d came about and why we are squaring the d. Maybe can somebody try to remind us how we got d and why we are squaring it, and maybe align that to what the 4-figure mathematical table is giving us, that we should get sigma f into bracket x minus x bar, then we square then over capital N. And somebody try to tell us why we got d, how we got d, and why we are squaring it in relation to the formula on the log table.
By taking x minus the mean and we square so as to get 0, such that is our formula sigma f d squared over a.
Your audio is not very clear. Can you come again?
Is the
One is not clear. Mr. Mburu?
Yes.
That one is not clear. Can't. Maybe it's network.
His network is not as strong.
Maybe.
Maybe somebody else can try. The question was, the log table gave us that for you to get variance, you get sigma f into bracket x minus x bar, close the bracket, you square, then over capital N. But for us, we are working with d squared, sigma f d squared over capital N, or over sigma f. Can somebody try to link the two for us?
Teacher, we got d as the deviation by taking x, which is I guess the midpoint, minus the actual mean, and then we squared it because using the deviation x minus x bar, we would get the total deviation as 0. So we squared it so that we could eliminate the negatives, and then yeah, I guess that's the answer to the question you asked, teacher.
Yeah, that is correct. The 4-figure is giving us the summation of f into x minus x bar. So whatever is inside the bracket, x minus x bar, as per the 4-figure table, is what we have as deviation. X minus x bar has been replaced by that letter D. Then remember, we are squaring it. We square that deviation. The same way the book is telling us, we say x minus x bar, then we square. We are squaring so that we get rid of the negatives that cancels out with the positive so that we end up with a 0.
Mr. Mburu?
Yes?
Can you allow me to write so that they can see what you are saying? Because I know typing can be an issue. Can write what you are saying as you talk.
Yeah, proceed.
I need to share. I need to share.
Let me quit sharing first. Proceed.
Yes, we are saying what Mwalimu is telling you, or is saying is, let me remove this. What Mwalimu is saying is, I have not seen the formula, but I could follow from what he's saying. Is just a minute, let me pick my pen here. What is this now? It's not. Okay. Sorry, just a minute. Yes, what Mr. Mburu is saying is we said variance is given by, okay, let me start for the ungrouped data. We said it's just summation. You take x minus x bar, you square that, and you divide by n. This is just the same as, instead of using x minus x bar, we can say let d equals to x minus x bar. So if we say let d equals to x minus x bar, now it simply becomes this one squared over n for ungrouped data. Then when we come to grouped data, what Mwalimu has just completed very well is just telling you this is the same as saying summation of, now there are frequencies, exactly the same thing we did up there. We are not changing anything, but we are not dividing by n because there are frequencies. You divide by that. But if we say let d equals to that, it means it is just summation of f d squared divided by summation of f. I don't know whether, Mwalimu, that is what you're insisting on.
Yeah, that was exactly my point.
Yes.
Because
so when they come across the two, they mean the same thing. Where there is a d, we are just replacing the component x minus x bar with the d, making it easy to manipulate. You know, when you write x minus x bar, looks huge, cumbersome, clumsy, tiresome to follow. But when you collapse that x minus x bar to a d, then it looks simple to manipulate. But we must know what is the source of the d. The d, as I've just shown up here, is simply the x value minus the actual mean. Then the other question Mr. Mburu was also talking about is, you are talking about whether it's 4SF. Yes, the standard rule is 4SF. However, it depends on the number you are dealing with. If I have a number like 1.378, I'll go for 4SF. But if the number was 12785, like that, I will not go for 4SF. And in fact, let's say there were even decimals, 0.078. I cannot go for 4SF when the number is in that format. I'll go for 2 decimal places. So this number, I will pick everything the way it is. So it depends on the nature of the number given. If the number is like the first one here, 4SF is admissible. If it's like the second case, you cannot work with 4SF. That number, you now proceed and work with 2 decimal places. Thank you, Mr. Mburu. You can summarize if that one is helpful.
Okay, thank you very much. I would wish now to maybe give you one that you can attempt. Maybe if you could allow me to share.
Okay. Let me remove this altogether. I think it was just a summary of the lesson. Okay, you can share now.
Okay, some random data. I hope my screen is visible.
Yes.
Yes,
Okay.
Ikosawa. From my end is very clear.
So let's have some table so that we could create some question. Assuming now this was the mark, then we have some class maybe from 10 to 19. We have a 20, let's say to 29. We have 30 to 39. And we have, let's say, 40 to 49. 50 to 59. Then 60 to 69. Then we maybe have the last one, let's say 70 through 79. Then we key in the frequency. So this is F. So let's say here we have 2. Then we can put there 5. Put here 8. Just using random. Put here 10. Put here 5. And we can say 3, then finally 1. So what I want you to do is to come up with the variance for that data set. Then you also calculate standard deviation. That is your take-home assignment. We come up with the variance. Then we as well calculate standard deviation. Variance and standard deviation for that set of data. So I'll give you 1 minute to maybe copy it. I believe now you are good. You've copied that. Maybe as we wind up the lesson, there is something that we should have mentioned yesterday. We are done with variance and standard deviation. Maybe we can look at the other dispersion like range, etc. Maybe in the next meeting. But before we finish up the class, there is something that is somehow linked with what we were doing yesterday. That is the quartiles and the median. We call them deciles and a percentile. Deciles and percentiles. Maybe I would give a volunteer to try and tell us what these two items could be. Using the knowledge we had yesterday that a quartile divides data into 4 equal parts. Median divides data into 2 equal halves. Quartiles, 4 equal parts. Median, 2. So what do you think would be the effect of a decile, or what is a decile?
10.
That is correct. That a decile would divide a set of data into 10 equal parts. A decile would divide data into 10 equal parts. So that maybe you are asked to get the 4th quartile. You are asked to get the 4th quartile. So how do you go about that? It will be 4 times n over 10. 4n over 10. Over 10 because we are talking about a decile. Times 4 because we are interested in the fourth decile. So that tells you we will use the same formula we were using yesterday. L plus something times n over 2 minus CF over F times I is the same formula. But now because we are talking about a decile, we say 4 times the number of items we have, then we divide that by 10. So the sixth decile therefore would be 6n over 10. That would be the sixth decile. Somebody else, what is a percentile? What do you think would be a percentile? Yes?
Divide data into 100 equal parts.
Yeah, it would divide data into 100 equal parts. Divides data into 100 equal parts. So therefore, what would be the first percentile? How would we write the first percentile? We will just say 1 times n over 100. 1 times n over 100. What about the 80th percentile? 80th percentile, we take 80, then we multiply by the number of items we have, then we divide that by 100. 60th percentile, 60 times n, then we divide that by 100. Make sure that you have that one correct. That is a decile as well as the percentile. So the same formula or a similar formula will be there for use where we talk of L plus. Now, if we are looking for the 80th percentile, we'll say L plus 80 times n over 100 minus CF over F times I. Any question?
Sure, could you please, there's something I was going through, but I couldn't understand. That is on ranges. There were some terms, interquartile range, semi-interquartile range. Could you please take us through that?
Okay, now that is the other measure of central tendency, a measure of dispersion. That is range. Range. So range is the difference between the highest score and the least score. The difference between the highest score and the least score. Maybe I can, let me see if there is something I can share on that. Let's say, for example,
there's nothing I can do, I can underwrite.
Yeah. Proceed.
I can just write.
Yeah.
Just okay. Just allow me to share.
Proceed.
I hope I got the question right. Somebody is asking. Range. And the Mwalimu has said the range is the difference. Range is the difference between the highest value and the lowest value. The lowest. So in other words, if we are to discuss a range in terms of a diagram, we are just drawing a diagram here. We say the lowest mark is 3, the highest is 12. So what's that range? The range is 12 minus 3. That's how you describe range, just the highest minus the lowest. That is range. Then before you take roll call, let me finish this. The next is, somebody asked about, I think, quartile range or interquartile range. Yesterday, we also looked at quartiles. And we said there are 3 quartiles. There is Q2, which is the median. There is Q1, which is the first quartile. There is Q3, which is the upper quartile. So we have upper quartile, lower quartile, middle quartile. Then when we talk of quartile range, it is now borrows from range. We have said range is the highest value minus the lowest value, which means now quartile range is the highest range, which is Q3, minus the lowest range, the highest quarter, which is Q3 minus Q1. So when you take Q3 minus Q1, what you get is what we call the quartile range. Then after quartile range, there's what we call semi-interquartile range. Semi-interquartile range. Just as the name suggests, semi is halfway. So you take Q3 minus Q1 and you divide that answer by 2. Let me move this guy, and you divide this answer by 2 like this. So when you do that, what you get is known as semi-interquartile range. This semi-interquartile range is also known as quartile deviation. So if you see the word quartile deviation and the semi-interquartile range, they just mean the same thing. So all those definitions are derived from the things we have already done. Range is highest minus lowest. We know the 3 quarters. Quartile range is Q3 minus Q1. Semi-interquartile range is half of the quartile range, which is also known as quartile deviation. Mwalimu, you can take Rocco as we see. The difference between range and the quartile range would be, I think I've already answered that, Noel. Take Rocco, guys.
Thank you, teacher.
What is wrong?
Now let's take Rocco first. We are going to allow you to shout in a short while, if you must. Let's keep doing it. Let's keep doing it. We are not yet there. Let's finish with the roll call. We have stalled. We are not moving. Please.
I think that
we are almost there. Around 10 of you to go. Around 10. I think, Mr. Mbiro, that's good enough.
That is okay, sir. Thank you so much. You can go ahead.
Okay. Mr. Mburu, are we done?
I believe we are done for the day.
Okay.
Maybe just to mention.
Yes.
Something we've not touched on is maybe data representation. In Form 2, we did histogram, we did the bar graphs. Now in statistics 2, we'll be talking about the ogive.
Derek, you can chat. Because Mwalimu is speaking.
We'll talk about the ogive or cumulative frequency curve. Maybe as part of your assignment, go read through cumulative frequency curve, or sometimes what it's called the ogive. And maybe sometimes it can be tested in a way that they require you to come up with the quartile, the interquartile range, the median, using the cumulative frequency curve, like we did in Form 2, where we used a histogram to come up with the median. So go through, read through cumulative frequency curve. I think that's all.
Thank you. Thank you, Mr. Mburu. Somebody is asking, why is it called quartile deviation? We say deviation is moving away from something. So it's deviating from the quartiles, the median. So Q3 minus Q1, that's the reason we call it quartile deviation. I'm just responding to a chat as I've seen in our chat column. Thank you, guys. I think it has been a fantastic time. We are technically done with the first topic in Form 4, besides those more elements that Mwalimu is talking about. So you should be in a position to comp through statistics, combining Form 2 topic in statistics and the Form 4 topic that we have just done. And when you come back, we may not repeat the topic 100%, but we'll just be doing some touches to complete the remaining bits. So take time, go through it, and I'm sure you will understand. Thank you so much for your cooperation and understanding. And I take this early opportunity to wish you a Merry Christmas and a Happy New Year. May God bless you all. Thank you.
Thank you,
Over
sir.
to Mr.
Merry
Mbithi.
Christmas, sir.
Thank you, sir, and Merry Christmas.